Greetings, everybody. This is a MHS Saber by APaul. He designed and built and basically did all the machining on this saber to build it out of MHS parts. I ordered this chassis off Etsy. It actually has to seat pretty far in there. There's a lot of engineering working out because the bottom handle was kind of short, so I didn't have much room to deal with. So the battery actually has to go into the saber here a little bit. You can see it's a struggle to get it out, but I did install a pull tab to get the battery out. The battery does actually go inside of the hilt a little bit, slightly. But I did put a tug there, so we'll be able to get it out easier. And the positive does go toward the speaker on this install. I actually changed that so I could put the positive on the switch. Made it a lot cleaner wiring it up. Um, but just gonna have a 28mm Smuggler's Outpost speaker, and the short handle goes back on. You can see inspiration, the red and green lights, the two buttons, the green, and the Obi-Wan Kenobi inspiration. Now inside the blade holder here, we have an MHS. This is a Tricree MHS holder, and I've adapted this Tricree MHS holder to hold a 7/8" Neopixel module. This was all the mock-up for that. And inside the blade holder, the hex bolt that holds the shroud on is sticking through a little bit, and I think this knurled thumb screw, that's what we're going to use for blade retention. We have to make sure it's flush when it's holding the blade in, so it's not sticking up too much, but this one's look like it's sticking out in through there a little bit. So I have to trim that up, and that's about it. Ready to rock and roll.
All right, Andy, this is your blade. Excuse the mess because this is what it looks like I'm in the middle of an install, but this is your blade holder, and there's your 7/8 blade lighting up in your 1-inch blade holder. I got the aluminum adapter in there now. I think that aluminum adapter is going to screw around with the shine through, so we may have to talk about that, but at any rate, I got that done, and I wanted you to see that. So there's your, red and green LEDs. This is me testing them with my test battery, but they're resistored. So the red is resistored with 180 ohm quarter watt resistor, and the green is resisted with an 82 ohm quarter watt resistor. It's the appropriate resistors for the red and green. Also, your chassis is already pre-wired, as you can see here. The switch is already in, and I've rigged this tug thing for the battery. The only thing unique on this Saber compared to my normal installs is your positive is going to be toward the rear. So when you snap in your battery, your positive is actually going to be toward the rear of the Saber, toward the speaker. Speaker's already in, and the speaker is wired. Those are the speaker wires. That's your positive battery wire, and your negative battery wire is right there. You're not going to be able to see it on this video, but your chassis is pretty much done. So I got to get that inserted in the Saber once I get all these. So I just got to wire up your switches because I think I showed you your LED. Like I'll show you the LED module that I was testing your. So there's your LED module that I made out of custom Saber shop, the old Tricree module, and there's your module right there with the wires coming out of it. Use 22 gauge for positive and negative, 26 gauge for data, and that's ready to rock and roll too. So the only thing I have to wire are the switches, and then it's pretty much ready for the Proffieboard and ready to rock and roll.
So here we are. We're trying to separate these wire bundles out, and see what we've got to deal with here. Basically, I'm trying to get all the wires out of the way that we don't need so we can do the positive merges. We have to untwist a lot of our bundles here, which is a pain, and I'm already taping some of the wires out of the way that I can deal with. Oops, forgot data wire. Gotta put it under the tape too. That's the data line for the main blade, that little purple wire, purple 26 gauge. And then we have these twisted bundles. The brown and red is for the green LED, and then the orange and red is for the red LED. And those are 30 gauge PTFE. So I'm going to separate out the orange. So the red is the positive. I always use red for positive anything. That's how come I can know I can merge all my reds, because they're all common. Which, to me that makes common sense on DC wiring, but you do you, boo. But at any rate, I'm trying to get the all the wires out of the way. Now I have to untwist these because I've got to get all these red wires where I can go ahead and merge them. So this is the brown wire goes to the green LED. The brown wire is the negative wire for the green LED. And the red wire, of course, is the positive wire for the LED. The resistors are already in there, as you previously saw earlier in the video. The resistors are already in there. Now we get to the red LED. These are the Luke Skywalker, control box LEDs that Andy, wanted on his Saber. It served as the inspiration, and I'll have them working similar to the Luke Hero control box LEDs when the Saber's running. So this is the negative for the red. I'm going to get it out of the way, that orange wire. So now we're all left with red wires. You have our wire coming from the battery, you have the two LED positives, and you have our other positive line coming down from the top of the hilt, which is our Neopixel positive. And we're going to put all of these together. So I want to strip it a little bit longer for these merges. And these two are 30, and they're way too long. I'm going to try to make it so that we have enough spare wire to, yeah, you can see there, and it's all the stuff's too long, so let's shorten it up. So that's what we're doing here, shortening up that main positive wire. And then we need to get these other wires in there. Oh, Jesus, Lord have mercy. So, that's one of the LED wires there. There's another LED wire here. It's 30 gauge. And then twist those two together. And then we'll cut this one to length. Strip it. This wire is coming down from the Saber. This, of course, is our 22 gauge positive Neopixel feed. I'm going to merge it onto these LEDs and twist all that bundle together, and then we'll solder all that together. Positives are positives, negatives are negatives. With the exception of your Neopixel negative and your LED negatives, which we're going to put those on FETs. So the FETs are like a switch that actually control those negatives that turn them on or off. The brain of the Proffieboard knows when to turn those FETs on to power those things based on, your config file. That's how normal LEDs work. That's how you can get normal LEDs to blink on a Proffieboard, is you just send the negative of the LED to a FET, and then you create a blade style for that FET. In your config file, you just have to tell the Proffieboard, hey, I got normal LEDs on our MOSFETs. In this case, it's going to be 5 and 6, and that way it sends power, to those, like it sends power and then turns it off, power and turns it off, and that makes those normal LEDs blink. And there's tons of tutorials out there to figure out how to do this, but now I'm buttering up the main positive wire that's going to come off the battery switch. There is a battery switch on this Saber as well. It's a high amp kill switch, which is in the chassis on the underside. It's on the same side that the battery goes in. So now we're ready to do these merges. We'll bring in the helping hands. And we also got to get some Heat shrink. Oh, forgot. Almost forgot the most important part. 26 gauge. Now this is going to be my my pigtail that feeds the Proffieboard. So we're going to put this 26 gauge into this merge, and this 26 gauge will actually have a loose end that will feed the positive on my Proffieboard. So instead of taking, you know, 1, 2, 3, 4 wires onto the positive pad on my Proffieboard, I can accomplish this via the merge inside the chassis, which will be underneath the Proffieboard and insulated. And to me, it's a lot easier taking one wire into the Proffieboard than it is taking 4. Now, of course, I could have merged the 2 LEDs and put them on the 3.3 volt pad, and that would have made it even safer for those LEDs. But you know, positive is positive. So to me, I'm going to go ahead and merge all this stuff. It's just the way I do it. It doesn't mean this is the right way. There's a gazillion ways to do this. It's just the way that I do it. Need some heat shrink and some open ends. Hopefully this will fit over that big bundle of wires. Check here real quick. Shortening up my merges here. See if this fits over the big bundle. Looks like it will. A little bit too long. And we have to shorten that up. You know, you don't want your heat shrink too close to where you're soldering, because it'll end up shrinking on you as you're soldering as the wire heats up. So, you know, I try to get it a little bit away from the wire, but usually these solder merges don't take too long, so you don't really have to apply a whole bunch of heat. So now you see I got my helping hands on the main positive wire from the battery, which also has the 26 to the Proffieboard pigtailed onto it. And we're going to merge these puppies all together into one big positive junction, a positive merge, positive junction. You know, on boats and RVs, you know, that use 12 volt systems, that use DC systems, you know, they'll use junction blocks for common, you know, for your positive and negative. Basically, if you think about it, they're just like remote battery posts. And we're kind of creating this with a remote battery post with wires and solder here. As that solder heats up, I'm going to try to bring these wires closer together. Yeah, I didn't like that. I want to bring these wires closer together when that solder heats up. I'm always looking for how they fit best together. Yeah, that looks really good right there. Yeah, that's a good joint. Give it a little tug. Feels pretty good. I'm going to go ahead and slide the heat shrink on over that joint, let it cool for a second, but we'll put the heat shrink over it. Zoom you all out here so you can see this. So to pull the heat shrink up over that big positive merge, which is a lot of wires all coming together. Focus, and we'll shrink this on up with my hot air rework station. That's how I shrink up my shrink wrap, with my hot air station. It works really well. I used to have a big clunking hair dryer thing, and you know, it's a lot nicer just having this on my station where I can just reach out and grab it and heat it up instead of having that big huge hair dryer that I was having to use. And, you know, if you use this, you can use a soldering iron for that too, but sometimes you could get your, you know, you mess your shrink up, you get solder on your shrink or whatever. So I don't know. I like the hot air rework station. So now I'm just trying to sort out wires here to make sure that wires aren't tangled, make sure that wires are going to be able to route the way I want them to route, and that orange wire was actually tangled in this bundle here, so, you know, trying to make sure that's all nice and neat. There's my speaker wires. Now they're bent backwards and taped down, but I actually have the speaker and the positive wire in a conduit of shrink. Here we go. All right, so here's our Proffieboard. You know, here's our two speaker pads. Our switch is going to be, well, this is LED 6, our switch. That's going to be our aux switch, and LED 5. Those are 5 and 6 are our red and green LEDs. Of course, 2 and 3 are our main blade. And then our main switch goes on this corner. And then main battery negative, negative from our switch grounds. Don't use any of these. And then our last wire that we'll be wiring up is this purple 26 gauge you see taped down, and it goes right here to data 1. And it's that simple. You know, this is a fairly simple install. Let's go look at the pin map. All right, so what I was showing you there really quick is on this Saber, you know, I was showing you which pads we're going to have to wire. So I don't have a data 2. This is a single blade Saber. It's fairly easy to wire up. Well, I say it's a single blade Saber. It's a single Neopixel blade Saber. It's actually a 3-blade Saber if you include the red and green lights. But, you know, I don't have any of these to wire up. I just have the 2 speaker wires, or they'll get wired first. Actually, you know, I usually do the LEDs 2 and 3 wire that first because I have to solder that underneath. So this will be the first wire you see me do, and then I'll come back and do the 2 speakers, and then the red and then the green negative lines go to the LED 5 and 6. LED 4 is blank, LED 3 and 2 are the main blade, LED 1 is blank. My battery negative will go here, my common ground for the switches goes here. I have nothing on these pads, and then the next pad you see me hooked to is the data, and then this Lightsaber is installed once we get data on. That's it. So now we're going to do the merge on LED 2 and 3. This is the way I do it. Again, this isn't the only way to do it. You know, you could pretend one of these pads like LED 3 and then stick your wire up through LED 2, and then don't solder it in LED 2 and just, you know, bend it over and solder it down to LED 3 and then come back and solder it into LED 2. It would functionally do the same thing. But the 22 gauge that I use, I have tried that. It's just, I'm too worried about damaging the MOSFET trying to bend that wire over. And I also don't want to leave any insulation on the underside, so I've never done that. So I just use this resistor method, and it works for me. It's resistor tail that ties these 2 LEDs together, and it leaves a long solder point for me to solder the piece of wire to, which we'll see. It's a lot easier to film now with I've changed up my methods where this will be the first wire that I actually solder onto the Proffieboard, because it's just a lot easier to do this wire on the back side of the board first, and then do all the rest of the wires which I come up from underneath. That's it. You know, it's soldered into LED 2, and now we, you know, cut it, and we'll bring it up on LED 3. There's the back side. Yeah. So we've already cut it, so now we want to bring it in through LED 3. So take my forceps here and bend that, bring it up in through LED 3, which creates a bridge. So why are we doing this? We're doing this because we're dividing the amps of the main blade, the negative amps, on a DC circuit. Power flows from negative to positive, kind of. I know there's different thoughts about that, but think about electricity flowing from negative to positive. A majority of the amps are on the negative line here on the Proffieboard, and where they go into the blade. Now, once they go into the blade, then they expend, you know, a lot of the power making the blade light up. So then when the power's coming back on the return line on the positive side, then there's a lot less amps flowing through positive. So that's why, you know, we're using two MOSFETs here, because one MOSFET may not be able to carry that amp load of the main Neopixel blade. It'll probably be all right for a little while, but you're going to burn it out. So we divide that amp load on the main blade by two, which, you know, this is why on some of these crazy blades y'all are building, I worry about the load on those MOSFETs, making sure that that we have enough MOSFETs carrying those loads. If you're going to use a triple or a quadruple um, strip blade, I would probably use three MOSFETs. I haven't asked Frederick what he did, but I would use three. But, you know, here for a simple, you know, two strip blade or a KR pixel stick, you know, using two MOSFETs should be just fine to divide that amp load. So here I'm going to add a little bit more solder on the back side just to make sure. And I'm also trying to push this wire over a little bit to give me a little bit of room. And then, you know, we'll be ready to solder on the main blade wire to that. I'm pretty happy with that. Got a little bit of room to bring in that 22 gauge wire and merge into that. And that's that. Bada bing. Here's the Saber. And, you know, we got our positive merges done. We got our wires taped out of the way. You know, the switches and the LEDs were already wired in the Neopixel module. I didn't show that, as well as the battery and battery positive and negative in the switch. But, you know, I've showed that in a lot of other videos. You know, switches are simple. You have two poles, one ground, one switch wire. It's pretty simple. So here I'm separating out my wires, trying to figure out the problem for me is that, you know, I use different color wires for everything, but I was out of wire that I usually use white for my battery negative, and I was out of white 22 gauge, so I had to use two black wires. So I had to use a black wire for my battery negative, but I also had to use a black 22 gauge wire for my Neopixel negative, and I didn't want to get those two confused, so I'm making sure which ones were my power wires here. So this short black 22 gauge wire I was pretty sure was my power wire. So I'm gonna actually put, you know, my meter. I gotta pop the battery in this thing. But I'm gonna put my meter on the positive and negative wires and make sure that, you know, you can see the positives towards the speaker there. And you can also see the tug strap that I put in, so you can get the battery out of there. So, you know, I'm gonna go ahead and hook my positive, my negative lead to the negative battery wire here, positive to the positive wire. And I don't have any juice here. I can still see it's 0.0 volts, but this does have a switch on it, and I might have had the switch in the off position. So I'm trying to get the, oh, yep, there you go. That was like a dual test. Number one, making sure we got the right battery negative wire. I got 4.08 volts there, and also it was a good test on my switch. So I can reach in under here and turn my switch off. I'm at 0 volts. That's awesome. So I know my switch works, because I didn't even test that. So that's pretty cool. Now, you don't want to touch the positive and negative here. You'll trip the battery protection circuit. You know, Mad Cow always covers those with insulation. But you know, we're just gonna rock and roll here. Separated out which ones are battery negative, which ones are Neopixel negative. Let's pull our Neopixel negative out of the bundle we had taped away to get it out of our way, and we did the positive merges. So you can see I've got my two speaker wires there, and I've got my Neopixel negative wire. And I'm going to cut my Neopixel negative wire to length, make sure I'm leaving enough spare so I have some wiggle room, but, you know, not so much that I can't tuck it in and get it out of the way. You should not see any wires on top of this Proffieboard when I'm done with the install. All the wires will be hidden underneath the Proffieboard, and you know, you don't want to leave too much wire. If you leave too much wire, it makes your job a lot more difficult with cram foo. So, I leave enough slack wire that I have enough room to pull the Proffieboard out of there and work on it, but not so much that I can't put it in the place where it's supposed to be. I know a lot of people I see installing their own Sabers are definitely leaving way, way, way too much wire. They got their board a foot above the Lightsaber or whatever, and they're, running all their wires to it. You want to try to install it as close to its position as you can so you don't have so much wire. That's what makes cram foo so hard, is when you have too much wire. But we're getting ready to do this Neopixel negative onto the board here. So I got my board and my holders here, insulated holders, I must say. This is a brand new magnetic rig that I have, which is making life a lot easier. And I know y'all can't see it, but I'm actually using my new headset. Part of the reason that I got a little behind in saber building is I wasn't able to see as well. My vision has gotten a lot worse, even with bifocals. And I'm going to the eye doctor this week, but, even with bifocals, it wasn't working out. I couldn't see what I was working on, so I was almost practically guessing. But now that I've got these, magnifying headsets, it's pretty awesome because I can actually see what I'm soldering again. And, it was making me nervous when I couldn't see. This stuff is small that we're working on. I'm, at the time of this video, I'm 51 years old. I'm not a spring chicken. And, soldering these small wires and pads, even 7-8 years ago, it was a massive difference. I started noticing the problem when, I'd be soldering with my glasses on, I couldn't see, and then I'd have to take my glasses off and I could see fine to solder. So I'd have to take my glasses off to solder. And then it got to the point where my glasses off, I couldn't see it anymore either. And that's when I got bifocals. And then, with bifocals, I could see the solder. And then, in the last 2 years, there's even been further degradation in my vision where, it made it even harder to solder. And it's got me a little bit further behind. And, I was reluctant to buy one of these, jeweler's magnifiers, but I did. And I needed it. But there, you saw the merge for the Neopixel negative. Next is our speaker wires. So we're going to have to bring our speaker wires up through here. They're 30 gauge. And I'm going to strip those. Now you can see that positive wire and the speaker wires are routed through that black conduit where they're visible in the chassis. And that's because, they do have to run through there, but I run them through conduit, and I also use E6000 to glue that conduit into the side of the chassis. And those are the only 2 exposed wires you'll see, but you'll see that black conduit, which matches the black chassis. So, you really don't, those wires don't stick out like a sore thumb, but they are the only 2 wires that are exposed, is the bundle carrying the speakers and the battery positive that run through that conduit, just to the right of the USB port on the Proffieboard underneath it there. All right, let's bring in a speaker wire here. I'm going to bend that over Jeff Birch method, bend it over. There you go. And then bring in some flexors. And there we go. And then I'll bring in my solder. Another thing is, don't use too big of a solder wire. Some people use too big of a gauge of solder, and that makes a mess too. This, fine gauge solder that I use, it's, really fine. I would say it's probably close to 30 gauge. I mean, it's very, very small. I think they measure it in millimeters, but, it's really small. You don't want to use a big solder wire, big thick solder wire like they sell at Lowe's or Home Depot, because it's too thick. You get too much solder on there too quick. That big solder wire is really made for plumbing. It's not really made for fine electronics. This wire doesn't want to Jeff Birch over. So you're gonna. There you go. Now to force it over. Bloop, 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 bloop. Good to go. So there's our 2 speaker wires soldered in. Next, let's see here. Yeah, orange wire. Now this is the negative wire from our red LED, and I'm going to put it on MOSFET number 6, so LED 6 pad, and this is the red LED negative. That's the orange wire we're dealing with there. And right now I'm kind of zooming out so you guys can see me cut this thing to length, but this is our orange LED negative wire, and this is resistor 2. And I showed you how much the resistor was earlier in the video, but so we've cut this thing to length. Now we're going to strip her. And then we'll twist, and then we'll dip, and then we'll tin this sucker. The reason you twist and tin these wires is you don't want strands. Man, I should have done that, so I'm going to put it away from the board, but you know, whatever. You don't want spare strands of wire touching things that you don't want them to touch, so that's why we try to twist and tin them together. And then, you know, the wire typically will come right up through the hole if I can get it straight here. I'm having Benji problems or something. All right, there we go. And, you know, now we're up through the hole. Go ahead and a little bit of fluxers. And LED 6. Bada bang. And that's our red negative that's on LED 6. And that allows us to control the LED 6, the red LED. It allows us, ooh, that's too much solder. It allows us to, cut that shit off there. It allows us to, you know, control that red LED to make it flash or to leave it steady on. I mean, we could make it do a lot of things. You can even make it match the blade and lock up. You know, you can make it flash on and off during lockup. So now the next wire is going to be our yellow wire. Now my yellow wire is the wire that goes to our auxiliary switch. Now I didn't show wiring the switches on this Saber, but I always use yellow, white, and green for my switches. And I don't want that yellow wire. Make sure here. But I didn't show wiring the switches on the Saber. Yellow and white are on auxiliary, and green and white are on the main switch. And I merged the whites because they're common, and you only have one white wire. So coming out of the switches, I have one white, one green, and one yellow. The white is common ground to both switches. The yellow is my switch lead for my auxiliary switch, which is the bottom switch on my Sabers. And the green is the top switch, which is I use for main. So this auxiliary switch comes up here on this corner, which is in the upper left of the Proffieboard here in this video. And I'm going to tin it. I already told you why before. I'm going to tin that sucker before we feed it up through. And then we bend it over Jeff Birch method. XX Sabers. I just like that because you used to have to, it was sometimes a pain in the butt, like the Proffieboard would move around on me, but bending those wires was just genius because then the Proffieboard doesn't move around and the wire doesn't fall out. It just made life a lot easier. You come in here and warm up the pad with the iron, and solder melts right onto the pad and the wire. That was a little bit too much solder there, but it's okay. too bad. We'll clip off the wire there. Try to get a little bit more of that off. All right, so now we're coming around to the other side. Maybe y'all can see the switches there. And, you know, now we're getting ready to go around the other side. So I wanted to I always try to work on the side that's closest to me. So I'm not reaching across the board with my iron. If you reach across the board with your iron and you slip, or your hands are shaky like mine, you might hit a component or something. So I try to bring mine in from the outside and, you know, hit it from the outside, so that way I'm not going over the board with my iron. I don't like sending my iron on the other side of the board. So here's the main switch wire, and I'm having to route it around all the other wires to make sure it's cut the length, leaving some spare, you know, like we've talked about this whole video. Leave a little bit of spare, but not too much, because cram foo. Twist, dip, 10. Oh boy, here we go. Get the phone disaster. Twist dip and 10. I'm going to bring that wire up through there. And we're going to go ahead and solder that on. Bring y'all in here so you can see it. A little fluxer on the Jeff Birch method. Now let's go ahead and solder our main power switch wire, our green wire, which is our main activation switch. I'm going to solder that sucker on there. Just like that. I run needle tips, and I'm running my gun at, or my iron at, I used to keep saying gun because I'm so used to working on bigger stuff. But I'm running my iron at 360 Celsius, which is pretty hot. But I'm using a needle tip, so that needle tip dissipates heat quickly too. So you got to run a needle tip a little bit hotter. If I was using a wider tip, you could probably run it a little bit lower than that. Might be able to get away with 300 or maybe even lower, but I don't know. You get too low and your solder gets goopy too. Too high and your solder flows, or sticks to your tip because it's so hot. So you got to find that happy medium. These needle tips on my gun like working at 360C. That's why I solder at 360C. Now if I'm soldering a bigger pad, sometimes I have to crank it up higher than that. But on these small pads on the Proffieboard. So I went ahead and removed the battery here because we're getting ready to get to, and I also forgot the green LED. And I forgot to put the green LED over here on LED 5. So that's what this brown 30 gauge wire is. And we're going to tin this sucker. And we're going to put this over on LED 5. I totally forgot about that wire. That stinks. But good that we caught it now, or else the green LED wouldn't have worked. This is the negative wire off the green LED. I showed those pairs of LEDs working, on my test battery in the beginning of the video. And now we're actually going to wire the negative wire of this green LED to MOSFET number 5. The positive wire is in our merge for this LED. Our positive wire already has positive return. This is hooked into LED 5 on MOSFET 5, which is a switch that turns negative power on from the brain of the Proffieboard, basically. a MOSFET's like an electronic switch. And those are those big square things like right near these pads. You see 3 on the top side, but there's also 3 on the underside. Those are the MOSFETs. Those are the electronic switches that actually provide power to LEDs 1 through 6 on the Proffieboard. And of course, this is a Proffieboard 2.2. Now it's hard getting this wire in there because I got all these other wires in the way. This is the mistake of forgetting a wire. Oh, but there we go. We got it through LED 5. We got it Jeff Birch through there. Oh, let's see here. Yeah, we're just going to come in and hit it. You see how my iron's going across that MOSFET right there? I really would prefer not to do that. So you see me coming in from this angle. Yeah, I didn't like coming across that MOSFET. All right, so there's LED 5, which is our green LED, which is the brown wire, but that's our green LED negative hooked onto the MOSFET. All right, there. So LED 1 is blank. You know, I showed that in the very beginning of the video. So now we're coming around to our main power wires. So the wires that I tested in the beginning of the video, there's that short black 22 gauge, which we know is our main battery negative wire. And it's going to hook on this. You see this, the first negative post with the long post going up behind the MOSFET? That's one we're going to hook our main battery negative to. And we're going to strip this. It is 22 gauges thick. Twist. These 22 gauges are a little bit more difficult to get up through the holes on the Proffieboard. But, you know, we're going to make it happen here. Trying to tin this away from the Proffieboard. Which, you know, it didn't work out because it's kind of a shorter wire, but you know, let's see if we can get that wire up through the hole, or do I need to trim it and work on it some more? You don't want to, these 22 gauge wires, if it doesn't go easily up through the hole, don't force it. You know, don't force it. So you're having to force it, you know, you could screw up the Proffieboard. You just want that wire to get up through the hole nice and easy. I'm going to butter that up with flux, and then we'll come in for the kill here. You definitely don't want to force the wires up through the hole. If you try to force the wires up through the hole, you could damage the board. You know, if it's too tight of a fit, then, you know, hit it with your iron again and try to, you know, trim any thickness off there. You know, try to get too much extra solder off the wire. 22 gauge barely fits through these holes, one that's pre-tinned. So, you know, you definitely have to be careful. This is why I don't do the fold over method, because it's hard enough just getting that wire through that hole, let alone getting it through that hole and then bending it over and soldering it onto a pre-tinned pad next door. I just never like doing that. It can be done. I can do it. I just don't like doing it. To me, it's too risky on the Proffieboard. That's why I do the resistor tail method on LEDs 2 and 3. But main battery negative. Let's come in for the kill here. Tin of my iron. Bringing in my headlamp lights. It's like so crazy that I can see now. It's kind of awesome. See, it's a bigger pad. It takes a while to heat up. This one's not one. It wouldn't want to take that solder. There it did. Right there. But that LED negative is a bigger pad because it's got all that copper trace that runs up and behind that MOSFET. It really didn't want to take that solder, even with flux. Sorry y'all aren't in frame here. But this next wire, this white wire, is our common ground for both the switches. It's our next to last wire. It's 30 gauge. This is common ground to both switches. So, you know, out of the main switch, I've got my green and white wire, and out of the auxiliary switch, I have a yellow and white wire. I did merge those two wires inside the hilt, the two white wires. The ground is common to both switches, and those two white wires from both switches are merged onto this single white wire, which if you guys have seen my other install videos, you see that I do that. It's easier for me to just take one wire to the pad, and they're common anyway. They were both going to the same place anyway, so I just merged them inside the hilt. And this is going to the pad right next to the main battery negative. We'll cut that to length, leaving enough spare, but not too much wire. We can't cram foo. You guys know the deal. We only have 3 wires left. Switch ground, main positive, which is our 26 pigtail. You know, you see sticking up, that red wire sticking up there, that pigtail coming out of our junction. And the purple wire, which is our Neopixel data for our main blade. So we strip this wire, twist it, dip it. Tin my tip here. Tip was a little dry. You know, you got to have a little bit of solder on your soldering iron to help it conduct the heat. Common switch ground to our ground pad. Now the ground pad and the battery negative pad are connected via trace. And that's okay. So you can see some of that solder leached over on that trace, but our hole's still clear, which is fine. I really had to throw the heat to that main battery negative lead because that pad didn't want to take heat, but this one should go a lot easier because it's a smaller pad. A bit too much solder. I had it gooped on my iron there. So I'm going to cut that off. And get our main battery positive wire cut to length. But and get all this wire out of the way. This wire's been in the way of the camera for a while. So same deal there. Trim it to length. A little bit of spare, but not too much, so we can cram foo. And it's going to go on this LED pad right next, or go on the pad right next to this common switch ground. Now this is 26 gauge. This is our pigtail that came off our merge that we made in the very beginning of the video. So it's a little bit smaller. And again, the main positive to the Proffie can be smaller because power flows from negative to positive theoretically. And you know, there's not as many amps on the positive line, so we can use a smaller gauge positive off our pigtail to feed the Proffieboard. So that's what we're doing. And you know, this is probably the most dangerous solder of the whole deal because this, you know, the way Frederick designed the board, and I got too much solder on that, so it's hard to get up through the hole. So I'm going to adjust this one a little bit. Remember I talked about you don't want it to be too tight, and see, I got even more solder on it there. I've got all gloppy. Yeah. All right. Let's clean up my soldering iron. Get all the solder off of it. Let's come in here and try to clean up this wire tip a little bit. So I'm just trying to clean up this. I got too much solder on this wire. When we tinned it, it wouldn't go up through that hole nice and easy. And it's still not going up through there. It looks like we got a wide tip on it here. Where are you guys? Oh, what a mess. Oh, there you go. Got y'all back in. We got you zoomed in. Zoomed in on the wrong place, though. Try to get y'all moved in here where you can see this battery positive. We're about to solder right here. So, bringing in my headlamp so I can see a little bloop action going on here. Bloop. That's a nice shiny solder. Good to go. Golden. Bada bing. Released my forceps. And let's pull this data wire out, which is the last wire we have to solder. And then we'll be able to test this baby. Stand by. I'll zoom you guys out so you guys can see what's going on here. Yep, there's our data wire. We're going to cut that to length. And clip, clip, clip. There we go. And I'm going to strip this thing. And twist it. And nip it. And then we're going to pretend this sucker, 26 gauge data. And this one goes to our data 1 pad, which we showed in the very beginning of the video. Get our forceps on this sucker. Or hemostats. And we'll poke this up through data number 1, which data 1 is pre-resisted on Proffieboard. 330 ohm resistor, I believe. And we're going to fold that over Jeff Birch style. We're going to zoom you guys in so you can see. I got my headlamp on with my magnification glasses so I can actually see what I'm doing again. It's awesome being able to see again. And there you go. That's our final bloop. Little snippy snip. And all the wires are installed. One Proffieboard installed. And I guess we need to put a battery in this sucker and see what we got. We got to put the SD card in too. Let's see how it's going to fit in its slot. It's looking like it's going to fit in its slot just perfectly fine. Awesome. Look at there. Not much cram food needed there. It fits just fine down its slot. We got to put a SD card in this thing. Let's get the SD card out. And I've already programmed this Proffieboard. It only has one preset on it. It's on OS 6.7. And SD card does have one font on it, just so I can test, which matches the config. And we're going to pop this in the Proffieboard. Missed. Pulled a Benji Graham there. All right. Now we're going to pop in a battery on top of the ribbon so we can yank our battery out. Positive goes towards the speaker, you can see, and we can make sure the switch is off. Positive toward the speaker. Now I'm going to turn the switch on. We should hear a boot.
He doesn't want to go with you.
Bada bang.
He wants your permission.
Ooh, the green and reds are flashing. Put a blade down in here. There's our greens and reds. There's what they do on idle. That's cool. There we go. Looks like it. And see what they're doing when it's on. And there's what they do when it's off.
Red, orange, red, dark orange, orange, gold, yellow, green, green.
Ah! It works. It's working. It's working.
Well, since I didn't get to go live tonight, but I did video this thing getting installed. You can see the shine through there too, Andy. Thank you everybody for watching as usual. I really appreciate y'all tuning in on my channel. And as always,